Hello, hello. All right. So I just completed the challenge that I was interested in. Passing test. Very nice. I noticed that I probably don't need this unit anymore because I can use a literal at this point. So let me get rid of unit. EXPR. So that I'm more on par with the book. Should have some passing tests. Okay, so I don't need a visit unit. Should not import random thing. And these can be literals. Nil. All right, back to passing tests. Let me check this out. Okay. What have I done here? I did the refactor from unit, and I did the new challenge. Let me do just the new challenge first, and then I'll commit the refactor to remove unit. So feature chapter 5 challenge 3 RPN printer. Okay. And then remove unit. All right, on to the next chapter. So, parsing expressions. So we got our scanner now, we can move on to parsing, and we'll construct this tree. So I'm interested in error handling. I don't think I've ever done that correctly. made me chuckle. I didn't know that the dragon on the cover of this is labeled to complexity. So we're going to get an answer to why the grammar in the last thing was ambiguous. Also, hello octopus. So we can get to this using this in two ways. We always start at expression at the top, pick binary, we pick number and use 6, operator is the slash, and the right hand is a binary again for these two things, with 3 literal minus 1 literal. The other way we can do it is pick binary and then do it for the left, right? So we can either have this nested, it's an ambiguous grouping because our grammar doesn't know, the order of operations, right? Yeah, okay. And here's it visualized as a tree. And of course they get different answers because orders of operation. So we get precedence. Of course, we have to evaluate the slash. And that's called precedence. Precedence. Associativity determines which operator is evaluated first in a series of the same operator. That's the opposite of how I've thought of associativity, because there's the associative property, which means that you can do this with, if these were plus signs, you could do this in either way, but this is kind of the opposite, saying you can't do this in either way. Hey Blobson. The yes operation. I'm only at parsing right now, but I wonder what should yes do? And where would I add it? I guess I would have to add it in the scanner. It's a good idea. So in my scanner, I already have literals that work. I don't, where do I handle and, for example? So it's a keyword. So I can add a keyword saying, yes is token type dot yes. I don't have no in here. But it's a great idea. How are you doing, Blobson? Or did you just come in and throw that bit of brilliance on my lap and run away? Perfectly fine. Assignment, on the other hand, is right associative. Interesting. Well, I appreciate that, but I think I was burned out after that, not only from Rust but from streaming in general, and like all the end of year stuff, like wrapping up work. So I had to take a break for a while. And I also, yeah, there's another thing too, which is that I want to be moving. There's a project that I'm working on with the stream, which you can read about at my website, esop.live. I don't know if that comes up as a link on chat. It looks like it does. Which is to make this into more of a conversational thing instead of just me staring at my computer. Rather be talking to people. But that will be a slow project, a slow build, so yeah, kind of like a co-op programming session. I think that would be a part of it. I think also just a conversation. You know, just learning about people who are learning to code and where they're at. For the purpose of, oh, just saw this. Don't know how that got there. For the purpose of sharing that conversation, sharing those words, and letting other people hear about it. Yeah, I think that's what I would end up doing. At the moment, yeah, VS Code has that. This is Emacs. There's a weird thing called Bluebits, which does that in a editor agnostic way, but I struggled with it. I tried to do, my first attempt at this channel was a lot of pair programming, and so I tried a bunch of tools like that. I think I would be more interested in just starting with a conversation, because like if you hang on Twitch, which I sense that you do, you're not just coming here for me. You see a lot of people asking the same questions over and over again, and there's this real need, a real yearning for like a place for newbies to hear about being newbies, right? You see all these people constantly coming in and asking questions like, what's the first programming language I should learn? What's the best language for X? And they're asking that to people who are not there and not in that place. Like, I don't want to say experts always, but people, often experts, like people who are working at a much higher level than those basic questions, and they don't have time for those questions. But who does have time for those questions are people who are at the same level and who are wondering the same things. So Really? Oh my gosh, Blobson. Well, welcome to Twitch. I'm proud and astonished. I'm certainly not the best programming stream out there, in my view. So, thanks for joining. I'm glad I got you turned on to it. But yeah, just hang out for a little while. You'll see that you get all sorts of newbie questions, and I would imagine that a lot of the lurkers here who are not ready to talk are people who are, you know, interested in programming, just learning to program, and don't really have the vocabulary to converse about it. And I think that's a real problem in the world, that programming is so opaque. So that's where I want to move towards. It's not, you know, this is fun, and I like doing my projects on stream, but I don't think that it's having the effect that it could. Right? Like, it's a little bit of entertainment for a few people right now, which I appreciate. That's not my end goal. And it compels me to do these projects, which is like, for example, this book, Crafting Interpreters, is something that I've wanted to work on for a long time. And streaming helps me focus towards that. So, but how are you, Blobson? Are you excited for the new year? Interesting. Is that on the thought that professors are more likely to be in contact with beginners, have a sense of how to talk to them, or what to say to them? I'm yeah, it's interesting. I have not thought of that. I have myself taught beginner programming in several contexts, but not at the level of a professor or even like a career teacher. It's my feeling that anyone who has programmed even a little bit has probably had a conversation with others about beginner programming, because there's so many people out there looking for, thinking about it. You know, everyone's heard that the jobs are great, or young people have played games or seen artwork or seen science that uses it. I feel like pretty much everyone out there has some sense that it might be interesting for them. Grammar stuff. Have you ever made a programming language, Blobson? Okay. Is it Programming is not your profession? Just a hobby or something you're looking into? Nice, nice. Okay, cool. I wonder if I knew that or not. You came in with a lot more knowledge of Rust than me, so I think I projected some level of expertise on you. Or maybe it was just your skill in doing the advent of code things. Are you in school for computer science or something related? Maths or something? Okay, cool. Awesome. Are you finishing in the spring? This explains why you know a lot more computer science-y things like graphs and stuff than I do. Cool, cool, cool. Wrapping it up. What kind of stuff in your CS degree was most interesting to you? Or alternatively, what are you thinking about doing in the future after you've got the degree in hand? Okay, so we're going to define a separate rule. Oh, for some reason I read this as worst interesting. And it gave me a chuckle, but I was totally wrong. Yeah, math is awesome. I'm not good at it, as you've probably figured out. But I think it's really cool stuff. Do you remember your context-free grammars and regular languages? Probably learned that stuff in like a foundational course. Bacchus-Nauer form, BNF. Okay, so we're gonna have different kinds of precedent. These are split up only for the purpose of precedence, which I don't really love because it's not, it's not clear that comparison has a certain precedence or associativity. Does this look familiar at all? This kind of thing? That's a kind of Bacchus-Nauer form. So basically right now we're parsing a programming language. That's the idea. Where we already scanned it and split it up into tokens, and then we're going to parse it into a tree structure. Okay, what kind of research and design? I mean, design has a ton of different meanings. Designing what, I guess, is the question. Or engineering what? except programming. Anything and everything, but one thing you know that you're not interested in is programming. Are you of normal school age, like 21, 22, something in there? Because I don't think this is not weird to me. I don't know if you think that is weird, but that seems pretty normal to me. Oh, you're really old. Like you have a career already? Okay, cool. Well, I'll be interested in finding out what you do with it. I mean, these are all really cool things. Okay, so I'm not really clear on what this chapter, like where he's going with this, but I guess I'll just follow along. Maybe I'll read it back later, see if I understand it better. Okay. Yeah, this does not seem to be the clearest chapter. Um, he's like filling in what's going on here. Kind of want to scroll down and see if he has the whole thing. Okay. So this is the complete expression grammar. So we're saying, we start at the top, we say, expression is an equality. Equality is a comparison and a comparison. Comparison is a term and another term. This does not seem... Oh, this has a star at the end. This whole parentheses thing. Parenthetical. So that means that equality might only be a comparison. And a comparison might be only a term. Or it could be a term with greater than or, you know, less than, whatever. A term could just be a factor. A unary, so this is only basic math, like basic arithmetic language. This does not have like, this is not a full programming language yet. A unary could be, or a factor could be a unary plus or divided by, multiplied by, and then we get down to unary. So this is just for like PEMDAS. And then it can loop back to the top if you put some parentheses around it. I feel like I'm just gonna skip over all of this. Maybe come back to it later, because yeah. principle, it doesn't matter whether you treat multiplication as left or right associative because it has the associative property. But because computers are real things, these might have different answers. Or yeah, in JavaScript, this would have a different answer. In pretty much every modern high-level language. All right. I've been going for about an hour. I might have to take a break and eat something here in a moment. Left recursive. There are many grammars you can define that. So yeah, left recursive is like a special thing in parsing. I do know that. I don't know much about why, but I've seen it before. Okay, you can define many grammars. We define a factor expression as a flat sequence of multiplications and divisions. Okay, all right. Recursive descent parsing, another knowledge dump here. All right, I think I'm gonna take like a 10-minute break here and get something to eat. But it's good to see you, Blobson. Don't feel bad. All is well. It's the new year. Everything's good. And if you're still here in 10 minutes, then I will say hi to you again. Did I play Descent 3? No. I played the original Descent. That's the spaceship game, right? Where you move in 3D space, and it's really kind of mind-boggling because you have to go through mazes in 3D. Yeah. It's pretty fun. I've not played any one that is newer than the oldest one, the first one. Yeah. No, I don't think I've ever played anything like that again. But I would expect more to come in VR to really make people nauseous. Okay. All right. I'll be back in a bit. I'm back. Guessing everybody's left by now, but that's fine. Parsing. Got all these different names. Pack rat, shunting yard. Interesting. Okay, so we're going to be doing recursive descent, a top-down parser. Pretty funny. The literal translation of the grammar's rules straight into imperative code. Each rule becomes a function. Okay. Interesting. So we can just take the grammar and basically parse it and build imperative code from it. I guess that's how things like egg and parser combinators work. Okay, so we're gonna make a new file, parser. Maybe I should finish making my yes operator special thing. I'm failing tests now. I shouldn't have failing tests. I think that might have been a, yeah, timing thing. Okay. Let's make parser.ts. And we'll import token type. Okay, we have a class parser, and we'll export that. It has tokens, which is a token list. This still doesn't want to import my custom token. I don't know why. Oh well. We'll import it and then change the import. Thank you. And we have a current. It's a number, starts at 0. And we're going to construct this, so we don't need to initialize it. Constructor tokens. This dot tokens equals tokens. Classic. Okay. So we're just going to run down the grammar, building up stuff as we go. The parser consumes a flat input sequence of tokens instead of characters. Right? We store lists and then a current to point to an index in this list. We're going to run straight through the expression grammar and translate it. So expression expands to equality. Okay, so we make a new function, private expression returns an XBR, the XBR, which we can import and it returns equality. Oh, I still have my multiple cursors. I didn't notice. Okay. They're gone. Okay. Return equality. This, of course, produces a syntax tree and returns it. When the body contains a non-terminal, we'll call that other rules method, right? This is why left recursion is problematic. The functions for a left recursive rule immediately calls itself, which calls itself again and again and again until it hits a Stack Overflow and dies, right? So if recursion is the first thing you do, then you'll just keep going, never terminating. Okay, so again, we have private quality, returns an EXBR, expression, and this has some code. So we'll say const EXBR equals comparison, so we'll have to write that next. While match token type dot bang equal token type dot equal. Hey, Papa Bean, welcome back. How are you now? This will probably, these will, right, this has to be this dot. We don't get that for free. This dot. And this dot. Java gives us the this dot context for free, but nothing. Yeah. You just relaxing today? Chilling? All right, const operator equals previous. right equals this dot comparison. And then okay, so we're gonna overwrite expr. Awesome. Awesome, awesome. Enjoying the day is the perfect thing to do. I'm going over to see some friends and try to stay up till the ball drops or whatever. Play some board games probably. Very exciting. But it's also the perfect day to get some stuff done on my little project. Okay. So, what are you working on, Papa Bean? I feel like you told me, and I'm forgetting. Yeah, board games are the best. Anytime you can, like, especially now, getting some actual FaceTime. Oh, cool. Well, I would love to see it if you're in a position to share it. Okay, we have write, and then we're overwriting expr with a new binary, which I'll have to import. AST node, and then import or unpack binary from AST node. Suppose I could do the same thing. Oh, awesome. I'm glad you're close to being done. That's great. I could just do AST node.binary. Why not? I can always fix it up later, but it just matches how I'm doing token type. AST node binary, expr expression, operator, write. And then we return that. This is saying we're building up a tree, a binary tree, right? We're looping and using whatever the last expr was as the left node of our tree. And returning it, but I'm guessing we're going to be doing that a lot. First comparison non-terminal in the body translates to the first call to comparison in the method. Take that result and store it in a local variable. Then this loop, right, so we're referring back to this grammar up here. Oh gosh, it's so far up. We're right here. We're saying comparison and then a while loop while we match either of these things, and then another comparison. Okay. So now we have some. Yep. Okay. So we need to build match. I'll put our helper functions up at the top. Match takes in a array of types, which are token type, and returns a Boolean. For each in token types, let me just look at this. Yeah, for loop is good because we want to early exit here. For type in token type. I don't use for in loops a lot, but I'm pretty sure this works. If this dot check type, another thing I'll have to write, advance. So very similar to the scanner that we wrote before, with the advancing the current pointer through. Advance and then return true, otherwise return false. Okay. We have our check method. Check takes a type of token type, returns a boolean if this dot is at end, return false, return this dot peak dot type equals type. Okay, more things to write. Advance returns a token if this dot is at end or not at end. This dot current plus plus, otherwise return previous. Oh, always return previous, whether or not we're at the end or not. Okay. More little functions here. Say is at end returns a boolean, and it returns this dot peak dot type equals EOF, which is one of our token types. Oh, and these should all be private. Private, what are we at? Peak. Peak returns a token, and we're just using a normal array, so we can just index into it at this dot current. And finally, previous. Very exciting. It's token. Return tokens, this dot tokens at this dot current -1. Okay. So we should be back on track. Yes, these are simple things. Match returns if we just if the current thing has the right type. Type string is not assignable to parameter token type. Oh, this is the wrong thing. Maybe it should be of. Okay, let me just convert this to a normal for loop, because I don't know how to use for in and I don't much care. Oh, actually, wait, maybe I do know. If type in instead of type string, no, I don't know. Oh, this is in token type. It should be in types. Does that help? That doesn't help. Does this help? Are you now, what are you? Okay, that's what we needed. Let for of, not for in. Okay. And we'll figure it out with some tests if that's totally wrong. Okay. So that's the infrastructure done. We grab the matched operator token so we can track which kind of equality expression we have, right? That's here. This is the previous. We combine the operator and its two operands into a new binary, and we keep looping. Yeah. Okay, cool. We're supposed to get a huge snowstorm here, so I keep looking out the window to see when it will start. They're saying we might get a foot of snow, which is very exciting. But also, yeah, we've gotten very little snow. We got like a dusting on Thanksgiving and then like another little tiny dusting, but yeah. So my current weather forecast says light snow right now, but I don't see it out my window. So we'll expect it very soon. Where are you in the world, Papa Bean? Have you gotten snow yet? Are you at a snowy place? Okay, returns the expression. If the parser never encounters an equality operator, then never enters loop. Oh yeah, cool. I'm in Colorado. I don't know why I thought you would know that I'm in Colorado. I'm in Lakewood, near Denver. Gotcha. Yeah, you guys should have gotten more than us already. Yeah, last year I tried to drive down to the Springs in a storm. That was a terrible idea. Terrible idea. What a mess. And I'm not in a car. I'm not in a Colorado car. Well, I'm in a car you see in Colorado. I'm not in a car that's actually suited for the weather of Colorado. Let's say that. Me either, yeah, I'm from Massachusetts. All right, so we have comparison now. We're just gonna be rolling through these. Comparison. Turns in EXPR. And right, we're gonna do the exact same thing basically. In fact, why am I not just copying this? And editing it. So this should be this dot term. And then we have different token types. Token type dot greater. Greater equal. Token type dot less. And token type dot equal. Okay, this looks kind of ugly. Maybe I will import all the token types individually just to save this ugliness. Hmm. Right, well, at least it fits on my screen right now. Okay, operator is previous, yes. And then right is term. And then the same thing. Okay. Virtually identical, but it matches different token types. That makes sense. And then term. Create a helper method for parsing a left associative series of binary operators given a list of token types and an operand. Yeah, I mean, how many more of these are we going to do? Oh, we're going to do several more of them. Yeah, I might do that. Why don't we do that? Private parse left recursive takes in a what is it going to take in? Token types and an operand method to handle. So operand, what's operand going to be? Is it going to be a function or is it going to be just a name? I think we'll make it a string for now, and then we'll dynamically access this, you know, at string. We could also make it a function, but I guess it's going to recursively parse or talk to itself. Okay, never mind. Operand string. Let's see. And then this token types thing, the same way we did it up here, right? Yeah, it's the same way we did it in match. Just use a rest parameter. And it's going to return EXPR just like the other ones. Now we can copy this as a starting point and say, instead of this dot, we're going to just access it dynamically. Same here. Operand. And this can be spread of our types. Okay, now it's agnostic, and now equality can just be, what can equality be? It can be return this dot parse left cursive with comparison and these types, like so. Right? I think that works. Same here. We say return this dot parse left recursive with term. And then I'll just grab these. Okay. This will probably be a lot easier to write for these 5 more we have to do. Probably a good idea to write some tests, given that we're dynamically calling these things now, but return this dot parse left recursive factor token type dot minus token type dot plus. Well, that was much easier. Okay. Multiplication division, we've got factor. Is this object-oriented rather than functional? Yes, it is object-oriented. Yeah. The book, actually, if you want to check out the book, it's craftinginterpreters.com. He actually explains why he is using object-oriented. You can tell because I'm using classes. So each of the files, yeah, so a dead giveaway is class, which you probably wouldn't have seen. And you can tell that I'm using classes because I'm writing functions like this, where, yeah. But that doesn't always mean that it's not functional, right? I mean, one of the problems is that functional and OOP are not mutually exclusive anymore, right? You can pass functions around. Yeah, exactly. And vice versa. So the vice versa, a lot of people don't like, but you can do it. And yeah, so I think you know, it's useful to learn how to detect it, but the distinction is less and less. Yeah. I was going to say something else, and I realized the distinction is less and less. Like, there is less and less of a distinction between the two. It's kind of a valid way to describe it. And actually, OOP is not even, OOP and functional are not even, that's not even the right slice. It would really be imperative and functional, which would be a slice. Or yeah. Imperative versus empirical. No, empirical isn't a thing. I think you might be thinking of empirical like with an E. Empirical, like science, like empirical evidence of or relating to the Earth. Yeah, that's not really a thing in programming. In computer science, empirical evidence is important. Like if you're testing how fast something is, your empirical observation of that would be important. But it's not really a thing. Imperative means like that, like this is imperative code because you describe the actions in the order that they should occur, and the order is important. Whereas something like Haskell is functional, and it actually doesn't matter what order things happen in. Haskell has a defined order for things to happen in, but because everything's pure, they can happen in lots of different orders and still have the same level of validity. Yeah, it's also like functional, and functional is often defined as declarative, meaning you declare what you want to happen, and the system figures out how to make that happen and in what order to do the stuff. Okay, this is a little different code it's telling me because we have a different thing in here. Oh, and this is an if statement, so we'll write this one literally. If this dot match token type dot bang token type dot minus operator equals this dot previous, right equals this dot unary. Wait a minute, this is recursive in and of itself. I'm a little scared of that. But okay. Return new expression dot unary operator. Right. Oh, these are AST node. Okay. Otherwise, we return this dot primary, which I haven't written. We look at the current token to see how to parse it. If it's a bang or a minus, we have a unary expression. In that case, we grab the token and then recursively call unary again to parse the operand. So, right, because we can have like minus, minus, minus. But we can also have minus, bang, minus, bang, minus, bang, which might not make sense. But figure that out later. Okay, we have another one that's different. Private primary. If this dot match token type dot false, return new AST node dot literal false. Okay, so if it's a false, return a false. If it's true, return true. That makes sense. If it's nil, make a null literal. Otherwise, if it matches a number, or a string, it's a specific kind of literal. Oh, I see. We need to pull out, we need to give it the literal from the token. Right, because we, then which number this number is important information for the parser. So we're just unpacking it and repacking it. If this dot match a left paren though, then we're probably going to reverse, right? If token type dot left paren, then we have an expression, right? This is the recursion right here, is that we're going back up to the top of all of our matches. Oh. Then we consume. Did I write consume yet? No, I didn't. Consume a right paren. And here's our brilliant error code coming up now, or error handling. So this will be interesting. And then return a grouping. Okay. We must find an end paren. If not, that's a problem. Right, this is an interesting observation that a parser does both building and error handling. Like, I wonder if you think about separation of concerns, if it would be valuable to write two separate things that do those things. This is interesting. It should detect and report the error, then not crash or hang, but it shouldn't run the code, right? It should be fast, report more than one error if it can. So continue to try to attempt to parse, but yeah. Right, cascaded errors we see all the time. Like if you break something, you get like 20 different errors, but really it's just the first one is the problem and everything else is due to that. Okay. You know you want to push it. All right, I think I'm going to take a quick break. I have to move some laundry around, and maybe move up my standing desk. So I will be back in just a couple minutes. right, I am back. Hopefully the laundry in the background is not too much. Okay, so we're going to learn about panic mode. So before it can get back to parsing, it needs to get its state and the sequence of tokens aligned such that the next token does match the rule being parsed. We select some rule in the grammar that will mark the synchronization point. Parser fixes its parsing state by jumping out of any nested productions until it gets back to that rule. And it synchronizes the token stream by discarding tokens until it reaches one that can appear at that point in the rule. Interesting. So it's like when you recurse, you have some broken chunk. So you recurse down, and then at some level you have a broken chunk. The assumption is that at some level above, that broken chunk won't be a problem. Right? Like let's say you have parentheses, and then proper parameter, bad parameter. You can jump back up and find the end parentheses. Intriguing. Okay, so we're not actually going to do the synchronized part until we get statements. That makes sense. We're writing code to parse a parenthesized expression. After parsing the expression, the parser looks for the closing paren by calling consume. Here's that method. Okay, private token consume. Whoops, writing Java, should be writing JavaScript or TypeScript. We have a type, which is a token type. We have a message as a string. And if we check this current thing and it is of the given type, then just advance. We'll move past the closing parentheses, for example, and we can proceed. Otherwise, throw an error. And we have to make a new error. Throw this dot error, this dot peak. So what did we have? And the message about what we expected. So private error takes in a token instead of a type. And a string message. And then it does the error thing. Okay, so I made a different decision about errors, that I wouldn't make them static, a static thing on the interpreter, but instead pass them down. So for right now, we'll just say this dot on error, token message, and return new parse error. Okay, so parse error is something we'll have to create. And that's what will be thrown. Interesting that we're reporting the error in two ways. Wait, didn't we already make this? Interpreter. Yeah. Does this take, oh, this takes a different thing. Ah. Okay, so we'll have to change this because they're relying on Java's overloading. So we'll have to mess with this a little bit. So you can see we pass in error to scanner. So let's say instead of calling this error, let's call it line error. And then we can write a different error, which is token error. That takes in a token and a message and does similar stuff. If token.type is a EOF, then report on the line in the token so if we're at the end, report at end. Otherwise, I don't know why we wouldn't use a ternary here. I kind of want to. This dot report, because both of them have token.line in them. And then here we can have this. So if it is, then we say at end. This on the next line. Otherwise, we say at token.lexeme, single quote, message. Okay, I wonder if we're going to add more to this if statement later, and that's why it's that way, but we can do that and come back to that, of course. Okay. Shows the token's location, the token itself. After we report the error, the user knows about the mistake, but the parser we need a runtime exception. So we need a new class. Class parse error extends, and I wonder what would Java use for a runtime exception? JavaScript used for in place of Java's runtime exception. And we can export that just in case somebody else wants to use it. Okay. Now this.on error, what we need is to do what we did in scanner in the constructor and take an on error. As a second parameter. And of course, this one takes a token instead of a line. And I think we also wrote a comment here. Yeah. So differently from the book, we're not using static methods. We're going to pass around an error handler. And save it. Okay, so now you should be happy. All right. So if we see that error that we just made, this parse error, we can test for that error exactly and unwind instead of panicking the entire code. Right. Oh, it's snowing now. That means I might have to skedaddle soon. We'll see. We shall see. Excuse me. Okay, so we're using the stack to know where we are in the parsing hierarchy, and then throwing an error to unwind that. And then we'll use a try catch. after a semicolon, a statement is over. Interesting. So when we run into a keyword, we can know that we were missing a semicolon if the previous thing wasn't a semicolon. Okay. So these are all token types. We advance past the thing we just messed up. Until we're at the end, if we find a semicolon, we're done. Otherwise, if we find one of these things that always starts a statement, we're done. Otherwise, keep going. Okay, so let's write this. Synchronize, if I can spell that correctly. Advance first. Then, while we're not at the end, if we hit a semicolon, return. Otherwise, we'll look for one of these things. Var if while print return. Now, this formatting is messing up. Okay. That looks a little better. After the switch, we advance. We continue advancing, looking for another one that looks right. We'll try this after we catch a parse error. We don't get to see this method in action since we don't have statements yet. Okay, so we're not going to do that yet. Oh wow. The snow's already catching on the ground. It just started. So that's generally how you know that it's about to get real. Okay, I'm near the end of this chapter, so why don't I just finish that up? As the parser descends through the parsing methods, it eventually hits primary. In none of the cases in their match, it means we're sitting on a token that can't start an expression. That's also an error. So inside of primary here, at the end of it, if we can't match a left paren, then we expect an expression and found none. Expect an expression here. Okay, and now we just need a parse method at the beginning. That returns an expression tree. Try to return this dot expression. Otherwise, oops. I don't think I can, like in Java, this only catches parse errors. I don't think I can do that. So I'll have to say if error, how do I test instance of parse error, then return null, otherwise throw error. So if it's not a parse error, rethrow. Okay. Parses a single expression and returns it, right? Doesn't do statements yet. We have some temporary code to exit out of panic mode. Yes. When a syntax error does occur, we return null. Right, because it's not usable. If there's any error in it, it's not correct. Had error gets set. Let's double check that had error gets set. In interpreter, when we report, we always set had error to true. Very good. All right, and here we're deleting this. And we're going to say const parser equals new parser with the tokens that we just scanned. And then our expression, the top of our tree here, is parser.parse. Of course, we're also going to pass in our error handler and import it. Now, if stop, oh, did it again. Okay. Stop if there was a syntax error. What are you complaining about? Parse is private. Ah. It should not be private. It should be the only public method. don't know why you're still saying that. I feel like... Okay, that was just a ghost error. Stop if there was a syntax error. If this dot had error, return. So don't continue. I feel like I wonder if we should not be parsing if we had an error in scanning. Interesting. And then here we can print out using that printer that we made in the last chapter. We can print it. This dot print line, new AST printer dot print expr. So this AST printer is still sitting in my test code. So why don't I grab that now? This test is gonna fail. This is expected. This one, this is interesting. Runs an empty program, now returns an error because it expected at least one expression, is what I would guess. Did it? Yeah. Okay. So, okay, let's fix this first and get our printer here. So that's going to be an expr test. We have this printer. Let's grab this. Why don't we put it in expr and just export it here? Okay, because it's directly bound to that expr class. That makes sense to me. And then in our interpreter, we will import AST printer from expr. Okay, so you're happy. My tests are still sad, but those are two, I mean, those two tests are just incorrect right now. Hey, Strager. Nice to see you. Are you wondering what I'm reading? This is crafting interpreters. I'm glad I saw that. This silly chat thing doesn't send me commands. I happen to have it open on the other screen as well. Which is actually, I asked you the other night, you know, how to point me to the chat API that you were using. I did not guess that it was the basic Twitch one, but I guess you are adding superpowers to on top of that package. So yeah, I'm doing this book. Bob Nystrom wrote this book. You write two interpreters in it. He writes them in Java, and I'm instead writing, or sorry, he writes the first one in Java and the second one in C. I'm going to do, or I am doing the first one in TypeScript right now, and then I'm going to do the second one in Rust, I think. Something that's not C. I might do it in Go. I don't know Go. I learned a little bit of Rust during Advent of Code. Not very good at it, so... but I just don't care to invest my time in C these days. Even if I don't have strong opinions on any other language, either Rust or Go. I don't have strong opinions either way. Yeah, it's a really awesome book. I'm having a lot of fun learning some stuff. You can see my code at my GitHub. And actually, one part that you might find interesting is that you might hate it too, but in, I think it's here, expr, yeah, right. So in this file, so the author generates a Java file given like type information. So you start with this type information, and the author writes a Java script, a script in Java, to output a valid Java file. And I didn't want to do that. So instead, I wrote a thing that uses eval to do basically the same thing in at runtime, which is terrible, but it's probably the only thing that I've done here so far that's tricky in any way. So everything else is super straightforward. But okay, right now we just got done with the parsing chapter. So we did scanning and parsing, and I think now we should be able to test the parsing in our web app. If I go to Chrome, we still have a bunch of TypeScript errors. Okay, let me try to fix these TypeScript errors. Except lacks a return type, implicitly has return type any. Oh. Cannot find these names. Yep, that's fair. I wish that my jest would print out all these TypeScript errors so I don't just have to find them when I look at the React application. I do use the TypeScript LSP. I'm probably not looking at these files very often, or I'm not seeing them. So this is expr.test. No, I was just in expr. Yeah, I'm here. This is on line 14 or 2. So this is a warning here, but it's an error here. So I guess my LSP and React have different thresholds. So what's the warning here? Except explicitly has this, it should return expr, I believe. Or no, I think it returns R. I think that's the whole point. Yeah, that's why this thing is here, I believe. Let me check where I'm using it, which is down here, to see if that's correct. So string, this should return string now. Yeah. Yeah, so it's this same R up here. That's what this returns. So yeah, I also don't have any way, like this is running Jest right now. I don't have any window open showing me, you know, all of the TypeScript errors in my code. Okay, 103. Right. Okay, these should all be AST node dot. I think that works, yeah. Welcome to the channel, Strager. I don't know if you know, but I'm a long-time listener. I've been popping in and out of your channel very often. And actually, the way that you are constantly helping people is pretty inspiring. I want to do something kind of like that. Not the way that you are doing it. Yeah, not the way you're doing it. I would like to have vocal conversations with people. That would be that's my next step on this channel. It's the direction I want to head. I don't know exactly how I'm gonna set that up and what it would look like, but I definitely need to get viewers. I mean, I'm not interested in like only talking with viewers. Really cool. That'd be awesome. It's not a viewer thing. It's more like I might, reach out to other people on social media and set up a time where we would talk and I would be streaming. So I'm not like only want to talk to viewers and only have like viewer chat. I mean, as you well know, the people who are viewers are a very diverse set of people, and I would like to screen to make sure that I'm not asking a crazy person to vocalize, right? Or maybe a troll is better than crazy. I don't mind a little crazy, but I'd rather not give trolls platforms, So I don't know what participating would look like, but thank you for the offer, and I will let you know. But yeah, crazy's all right, but I will let you know. Let me ask you this: do you have like a preferred, if we were to talk about Zoom or Discord or something where we could be talking and sharing a screen? Do you have a preference or an idea of one? Or maybe that's not a big deal. I think I would choose Discord, but I don't know what people use. Yeah. So my idea would be like you would be an outlier in this idea. My idea is to be talking to people who are relatively new to programming and to be having them talk about stuff. You can see more about my crazy idea at my website, like where I've just written out some of these ideas. And the idea is to give a place where new people can hear other new people talking. And you're definitely an outlier there, obviously. But not that, having an expert or an experienced person on wouldn't be a problem. It's not the exact direction I want to go. Because of course, you already have a platform. People can go hang out with you and even ask you questions because you're that kind of person. Oh yeah, I only got the joke part of that, but yes, that would be an interesting thing to do. I think I'll want to try doing it myself first, and see what it looks like and try to think about how I would like it to go. But yeah, in the future that might be fun. All right, what was I trying to do? Oh, I was fixing type errors. I can do that while we talk. Yeah, so I don't think, my point there was that I don't think that having your face or like the second party's face on screen would be important. And in fact, I wouldn't want to do that because I'd want the barrier to entry to be really low. So people who might feel uncomfortable with their face being broadcast would probably feel a little more comfortable if it was only their voice. And so I think it would only be me and I think I'd just be taking notes, like what would be happening on screen at that time is just me taking notes. And then maybe if the conversation progresses and we have fun, maybe we can find, you know, an activity to do together, like screen sharing or something like VS Code's live share, something like that. Actually, do you know of anything like VS Code's live share for Vim? You use Vim, right? I'm pretty sure. It's not assignable. Right. Interpreter 17. Well, I don't think so. At least in VS Code's implementation, you actually don't. You get to share only like a single directory, for example. Yes, yeah, I've done that before. I've actually done that with my own computers before, which is really fun. So I have an e-ink device, and I used to SSH and screen onto my more powerful laptop, and like type with a Bluetooth keyboard with my e-ink screen in front of me, basically making an e-ink like TTY for my computer, which is really fun. Syncs my Vim buffers. Yeah, I've thought of this too. I think definitely like yeah. Yeah, now I have an e-ink device that's powerful enough. Oh, thanks for the follow, Zelda fan. I have an e-ink device that's powerful enough now that I can run Termux, the Android terminal emulator. And so I run that, and that's a lot of fun. I really like just to do some writing. It's really nice to not be staring at a screen or an LED screen. Okay, I don't know where this error is. Line 17 on interpreter.ts. Ah, right. Help if I pass the right one. Okay, next one. Null is not assignable, right? Because I'm using TypeScript and not Java. Parser 24. Yeah, well, I appreciate your interest, Strager. I don't know exactly what I'm going to do with it, where I'm going to go. You know, for right now, I'm happy with my very chill stream, which is just me reading a book and doing book things. Advent of Code was fun, but I wasn't very good at it. And, you know, I get to focus on reading a book that I've wanted to read forever. So this has a return type expr. I mean, can we just say or null? I don't know if that's really what I would like. Oh, thanks for the follow. Appreciate it. Okay, more TypeScript errors. Now that thing that I just made is not assignable to parameter of type expr. So I guess if I get a null back here, let me go there. Interpreter 23. It's if I get null back here, I can say, or I can even say not. Then or parsing error. And then I don't want to proceed. Does that make sense? Well, it got rid of the bug. We'll see if it makes sense later. Okay, element implicitly has any type because expression of type string can't be used to index type parser. Oh, bummer. Okay, so here I used parser 63. I wanted to dynamically call a certain function on this same class. I don't know how to do this in TypeScript. To basically say that this class is allowed to be accessed via strings. I guess I could say, yeah, tsignore, or like even crazier would be this as, you know, s in string to function, you know. Like I kind of want to know if this works. No, you hate this. You hate everything. Conversion of type this to type may be a mistake because neither type... What? What's the whole error here? Oh, that wasn't helpful. Because neither type. That's not helpful at all. Maybe a mistake because neither type sufficiently overlaps with the other. Convert the expression to unknown first. So do I do as unknown? As... And now you're happy? Okay, I think a tsignore with a comment would be much better than what I just did. So let's do that. And we'll say dynamically access this class as this class's methods with a string. Basically just saying exactly what the line does. That's probably not helpful, but that's why the tsignore is there, at least. Okay, one more. Parser 68 has any type. We're doing the same thing again. Right, same exact thing. Maybe I'll just grab it once here. Let operation, or these are like grammar. What's a thing in a grammar called? I don't know. Operand parser. Yeah, I mean, it might not be an... Actually, I don't know why I use the word operand here. Right, this can be anything on the left-hand side of a BNF grammar. Because that's what these are. That's what these represent. Precedence level parser. Yeah, that's what this is doing right now. I think this parser will get more and more complicated. Oh, this is really interesting, actually. My LSP server does not seem to find any problem with this, whereas the React one does. So I'm using, yeah, like there's not even a green squiggly here, which was where I got a warning before. But okay, are you happy now? Hey, you're happy. Okay, let's write some code, like 4 + 5. Hey, look at that. It does the thing that it's supposed to do. Right now, it's just walking the AST and then printing it out in like Lispy ways. Or let's do 1 + 2 minus, and we'll add some random white space here. 4 times 42, 52, I guess, is what I typed. Okay, and that's right. Cool. Cool. Okay. So we've got something done. Obviously, the end goal for that web app will be an actual parser or an actual REPL, but right now, just a parser. Okay. Yeah, I don't know what it's called. I'll leave it for now. It's fine. Names are easy to change. Hard to make right, but easy to change, right? All right, so we're at the end of the chapter. We have some failing tests. Ooh, we got a parse left recursive of undefined. So at some point we did something wrong. Somewhere in this mix, we did something wrong. So like here, we only have 2 failing. Now we have 3 failing. Why? How could that be wrong? Wasn't that the same thing? I have no idea how that fails. Whoa, that's not what I wanted. Vim fail. Oh, I know why, because I'm taking it out of this context here. Now, like, I would have to do like bind or an arrow function. Oh, how do I do this? I don't want to use bind. That seems such a silly use of bind. Or even an arrow function. Maybe I'll just do the same thing twice. Okay. Okay, back to 2 failed. And these 2 tests just feel like incorrect now. Like empty expressions. Which test was this? How did it work in the REPL? I don't think it did. It didn't, because I hadn't. It did. What? I don't know. Maybe I'd never. I don't know. Maybe I didn't save. Let me go back. Oh, no. I erased that code. It's a good question. I don't know. I felt like I was about to sneeze, but it's gone. I don't know that I care to explore, but it's a really good question. I kind of want to be wrapping up here. I don't know. Tell me if you are super interested in why it worked, and I will go explore it. Okay. Interpreter.test runs an empty program. It's way up here. I mean, can we just put like something simple? Yeah, okay, so let's say runs an almost empty program for now. I don't think that test will last. Anyways, okay, and then we have these output things. I guess we can now look at the REPL and say, you know, 4 plus 5 should output this. If I do this, no, if I do 4 plus 5, then the result should be this. Another Vim fail. Plus 4 or 5. Right, I think we should be failing on the second test now? No. We're missing a new line apparently. Okay, now we're at the second one of these. So if I do another one, like a more advanced one, so I'm testing now, I'm having my interpreter collecting all of its output into an array or into a string, forget which one. I think I'm collecting in an array and then output calls .join on the array so that it's like carrying that state around so that React doesn't have to carry that state around. Probably take that out in the future and have React hold on to that state. Makes a little more sense, but right now that's the way it works. Okay, and I'll make a little more advanced one. Parentheses. And a multiplication. We'll see what that outputs, and we'll just grab that. Okay, back to passing. So like this test is not going to last, so I don't care that it is formatted weirdly. It's only testing that I'm not breaking where I'm currently at as I move forward, and we're only at the parser so far. Okay, so let me commit everything I have so far, which is quite a bit. I have a whole new parser and many changes to many things. First, let's look at parser. I'm just going to review real quick, make sure it looks okay. Looks like what I expect. No random comments or missing things. Yeah. Okay. So we'll just add that independently. Parser almost verbatim from chapter 6. Now we made a bunch of changes elsewhere. We moved the AST printer from the test into its own place. Let's see. Yeah. Yes. Chore refactor AST printer into the Expert file where it lives with all its friends, the AST node gang. Now we fixed that test, but that won't make sense without this stuff. So we could say we are using the parser in interpreter now. What did we add here? Oh, I added a yes operator to my language. One of my viewers suggested that I should probably add a yes operator because, well, obvious reasons. Doesn't do anything yet, but there it is. Okay. And actually, I made some change somewhere else to include that in the scanner. Did I already commit this? No. Okay, there it is. I just hadn't saved it. Okay. Let me remove this and only commit my yes operator changes. preliminary support for the yes operator. All right. So the interpreter now supports, I'll include this bug fix. So the interpreter now supports yeah. Yeah, I kind of hate it. But it's the masses have spoken, and it will always be feet from here on out. It's like, why is every change that I make a feature? Whatever, doesn't matter. Okay. Interpreter now scans and parses. Yeah, new or addition, right? Add. Yeah, I mean, I only would follow them because they promise to be able to make, like, that tools will be built against them or are built against them, like the change log stuff. Yeah, you can always write your own tools, right? Okay, and now this stuff is for, I tried to make a CLI inside of Create React App, and it just didn't. I would have to mess with Webpack and stuff, and I don't want to do that. Hey, thanks for the follow, Supa Divisor. My language will have divisors in it. Okay, I'm going to push, and then I'm going to take a glance at the challenges at the end of the chapter, and then, oh, there's a whole nother section here. Welcome to the channel. Welcome to the channel. So I'm just finishing up chapter 6 of Crafting Interpreters, the book, where we have made a parser today, a basic parser, but a fun parser. Thank you. That's what I'm here for. I'm trying to focus myself. And it's also like snowing outside. Like right here I have a window, and it's total you know what, lo-fi girl. Like I'm reading a book, got my headphones on, got some lo-fi going, and it's snowing outside. It's a great day. So I'm going to take a look at these challenges, and then it is snowing, so I might have to head out soon as well. Because I need to, or I want to go to a New Year's hangout with a couple friends, and it's snowing, and I might not want to drive if it snows more. Excuse me. Okay, in C, a block statement. A block is a statement form that allows you to pack statements where a single one is expected. The comma operator is analogous. A comma-separated series of expressions can be given where a single expression... Hey Rambo, welcome to the channel. Yes, I was graced by the man himself. The man, the myth, the hair. Okay. A comma-separated series of expressions can be given where a single expression is expected, right? At runtime, comma operator evaluates the left operand and discards the result, and then it returns the right operand. Add support for comma expressions. Give them the same precedence and associativity as in C, write the grammar, and then implement the necessary parsing code. I have not written down the grammar because he presented it in the book, so I haven't written that down anywhere. But I suppose it would be like expression, comma, and then, or parentheses, comma, like, here, I can write it here. Expression is expression. Oh no, we can't have, hold on. Comma, I'll call it commas. Commas is an expression, and then a literal comma with any number of expressions like that. Something like that. Now, where is it? What's its precedence? What its precedence is, I do not know. I could go find what its precedence is in C. We can look that up real quick. Operator precedence in C. Give me a cheat sheet. Here we go. Search for a comma. It's at the bottom. Okay. Great. And its associativity is left to right. Much like all these other things that I already have. Yeah. Okay, so it being at the bottom means that I think that it means it goes at the top, right? Because like plus and minus are underneath. Oh no, that's plus equals. Plus and minus are underneath multiply and divide. And here in our code, which is in parser, we have minus and plus on top of slash and star. So what that suggests to me is that whereas right now expression starts with the equality, we actually want to have expression start off with comma, and then we write private comma returns an expression, and the type that's allowed to be there, it's going to go down to equality. The next step is equality, and then the only thing here is a comma. Okay, so I think that's all I need to do to add support for comma separated lists. Let me try it here. 4 plus 5, comma 5 minus 3. That didn't do what I expected it to. What did I expect it to do? 4, 5. Oh, it's not discarding, or it's just discarding the rest. So let me look here. First, we call equality, and that all goes, we'll get all the way down to primary, where it will match a number. So that's step one. Step two is while we match type, so while we match a comma, which we should, I might have to debug that further, then the operator will be a comma, and right will be, again, equality. So we'll go down the whole chain there. Then we make a binary out of the expression on the left, expression on the right, which should be two binary things and the comma between them. Now, it might be that my No. I expect this to print out parentheses, comma, and then two sets of parentheses with the two binary things. Why don't I try not two binary things on either side? Yeah, it doesn't seem to be liking that. Let me check if there are errors. No errors reported. I'm not sure why that's not working. Oh, there's some errors, TypeScript errors. I'm just restarting the application. Oh, that did work. I did not expect restarting the app to work. That's so weird. Okay. I accept. But okay, that seemed to work. Let me try a more advanced one. 4 plus 5, 5 times something. Right, okay. That's the expected result. React, you have thwarted me again. Don't know why. But okay, let's throw that in here. Chapter 6 challenge 1 comma operator parsing. All right, add support for C-style conditional or ternary operator. What precedence level is allowed between these two? Is the whole operator left associative or right associative? I think the whole thing is left associative. I can check that with my table here. Ternary is right to left, not left to right. Okay. Note 3. The expression in the middle of the conditional operator, let me make this a little bigger. The expression in the middle of the conditional operator between these two is parsed as if parenthesized. Its precedence relative to question mark is ignored. Okay, I think what I'm going to do is write myself a note here in parser. I'm going to say, I think it's down here. Where did I see it? It's 13. It's above plus equals. So it's between, or is after equality. So under equality, I'm going to say to do support ternary, we'll say C-style ternary operator, and see here for associativity note. Okay, and I'm going to leave that as a note for myself to do next time. I'm also going to capture this URL in case I don't do it. Oh, it's chapter 6. I might have messed that up. But okay, I think I'm going to leave that for next time. And then the last challenge is to add more error reporting, which I will probably do. But okay, all right. Well, thank you for the follows. Thank you for hanging out, everybody. I am going to sign off now. Should I raid? Strager, are you on? Yeah, thanks for hanging out, SuperDivisor. Who's online right now? RWX Rob. Let's raid Rob. All right. Hey, thanks for the follow, Rainbow. And thank you all for hanging out. And I'll see you next time. I don't know if Rob's doing anything. He might not be there, but we'll raid. We'll say hi. All right. And yeah, talk to you later.